Hello everyone, how are you doing today? So welcome back to our next session, that is solid principles. So thank you for the previous session what we have watched our videos. Thank you so much for supporting, and few of our candidate have asked to prepare a video on solid principles because this is the most interview question asked in nowadays. And according to the fresher or his experience, you should have to aware about what are solid principles are. So without wasting our time, let's get started. So if you are already seeing my screen, then you are seeing it. What is our today's agenda? Our today's agenda is to discuss about solid. What is solid? What are the solid principles? On the solid principles, what are the principles we have, that we call it as a single responsibility principle, SRP, OCP, open close principles, Liskov substitute principle, in interface segregation principles, dependency inverse principle. Why we need solid? We should have to a great knowledge upon a great understanding why basically we need solid. What are the problems? What are the problems we are having without solid, and how we resolve it with solid? What are the advantages? Some real-time examples of solid. What is tightly coupled? These are the few of the topics what we are going to discuss on our next session. All those principles we will be taking one session to understand with real-time examples. What are SRP? What is OCP, LSP, ISP, and DIP? These are the things we will be taking in each of the session. So first we will understand what is solid. So solid is an acronym, and it stands with 5 different principles, which we will discuss one by one with each real time and with a simple example. So solid design principles introduced by Robert C. Martin, and solid design principles are the design principles that help us to resolve software design problems. It will give you flexibility to remove tightly coupled codes. Okay, so that's why we have added this one. What is tightly coupled? We'll understand this with an example, which help developers to design software flexible and maintainable code. So what I said is, so solid design principles are the design principles that help us to resolve software design problems. Okay, it will give you flexibility to remove tightly coupled codes. What is tightly coupled code? We will just discuss about what is tightly coupled code in a minute, which helps developers to design software flexible and maintainable code. So if you're remarking 3 things, few of the keywords what we are saying is what is tightly coupled, what are uh, flexible codes, and maintainable code. So these topics we will be discussing in a very detailed way when we will discussing all our principles. First we'll try to understand what is tightly coupled tupled applications are. So to understand solid more closely, first of all we should have to understand very in a detailed way what is tightly coupled applications. Okay, so what are tightly coupled applications or classes are? So just suppose, take an example. Suppose that you have one class, we call it as a cars. We have another class, what we call it as a Toyota. You have another class, we call it as a Mercedes. Okay, or so there is a requirement in this car, there is a requirement of Toyota object. So what you did is, like, you are creating an object of Toyota class. So Toyota T equal to new Toyota. Okay, and in this constructor you are passing 3 parameters. Suppose that 1, 2, and 3. Okay, and there is also requirement of Mercedes object here. Mercedes M equal to new Mercedes, and here also you are passing 4 parameters, 1, 2, 3, and 4. Okay, now what happened is, in future it was running very well. You call the methods of this Toyota classes here, and you were using it, it was working very well. So what happened is, in Toyota there is some change. What happened, like this Toyota Toyota, in the constructor, they have added one more parameter. What you called it as a 1, 2, 3, 4. Okay, and Mercedes have removed one parameter. Okay, 1, 2, and 3 only. There is 3 parameter now, and now here. So immediately, if you are seeing it closely, this will start breaking. This cars will start breaking, and it will hamper your existing client also. So what is happening here? What it is happening here is there is a change in a Toyota class, but indirectly you are seeing it. You should have to make changes into car classes also, which will impact more. How it will impact more is in the term of testing, because you are making change of Toyota in the Toyota classes. You should have to test this car classes also, because indirectly you are making change to this car classes also. Okay, so there is a maybe regression test is required, or maybe is possible end-to-end testing is required. This cost lot to the company. So what it is happening here is Toyota class is a tightly coupled with a car class. Any changes you are making to the Toyota class, you should have to make changes to car class also. Or any changes you are making to the Mercedes class, you should have to make changes in car class also. So suppose that in future maybe multiple other classes also will be coming. Okay, so the changes you are making here is directly impacting to this classes also. So that we call it as a tightly coupled applications. Similar way, this is an example of a class. Similar way, there is one module which is depending upon another module, and if there is a change in one module, if it is indirectly hampering the other module also, that testing development or changes is required, then that we call it as a very tightly coupled with this application. So such problem basically Solid resolve it. So this solid have some principles. By following those principles, if you'll follow it correctly, it will help you to design a good software, maintainable software. What does the maintainable means? If any changes you are making here should not make directly impact changes to these classes, or any changes you are making in this module should not make any changes to this module. So hope this makes clear what is maintainable code, what is tightly coupled code. Okay, so one by one we will discuss about all of the principles available here in Solid and what are the Solid design principles says. Now our next topic is to understand Solid, what Solid is. So our first topic is single responsibility principles, what we call it as a SRP. And this principle states that a class should have only one reason to change. A class should have only one primary responsibility. S means S means single responsibility. If you're designing one class, that class should be responsible for only one thing. It should not be overloaded with multiple things. We will be discussing this SRP in a very detailed way with a great real-time example, so it will help you to understand the SRP. Our next is open close principle. This principle suggests that software entities, that we call it as a classes, modules, function, etc., should be open for extension but closed for modification. You should be able to add new functionality without changing the existing code, without impacting any existing client. With that, use of interfaces, abstract classes, and a design pattern like strategy pattern. Next is LSP, what we call it as a Liskov substitute principle. This principle emphasizes that object of a derived class should be able to replace object of a base class without affecting the correctness of a program. I know this Liskov substitute principle is very confusing, and believe me, I will be giving you a very simple example to understand this Liskov substitution principle, and it will help you to understand Liskov substitute principle in a very simpler manner. Our next Next is ISP, what we call it as a interface segregation principles. What this ISP says is clients should not be forced to depend upon interfaces they do not use. What does ISP I said is clients should not be forced to depend on interfaces they do not use it. Keep interfaces small and focused on a specific functionality. What does it in simpler way mean is, suppose if some of the interfaces you are integrating it, you should have to split your interfaces in a manner so the other client who are going to implement it, they should not be forcefully depends upon the interfaces, and they are forcefully asking them to implement it. Our last one is a dependency inversion principle, DIP. This principle focuses on the direction of dependencies between high level module and low level modules. High level modules should not depends on low level modules. Both should depend upon abstraction, that we call it as with the, depends upon either on the interfaces or abstract classes. So with this, all these solid principles, whatever the solid principles I have discussed, you will be if you're following this properly, you will able to resolve few things. What is maintainable code, removing tightly coupled, flexible code, reusability, testable, and few more. So these are the few of the solid principles. So if you are following the solid principles and designing your application, you will be coming up with lot of advantages. What are those advantages? Very less tightly coupled, testable code, reduce error. Why we are saying it is reduce error? Because if one module is not depending upon another, you should not have to, if there is a no change coming to the another module, you should not have to again retest it. That's we call it as a reducing error. Increase readability and extensibility. Why we are call it as increased readability? If you are following solid principles, other developers who is coming to your company, they will easily understand their code. What are the modules depending upon each depending on other modules. Code reusability, of course. So code reusability, because you are designing your software in such a way while following the solid principles, so you can reuse your code. Scalability is another factor. So if you want to extend your module or a feature or a software, it will be very easy to you to integrate any new feature into your application if you are taking help of the solid principles and with some of the recommended design patterns. So our next topic is also coming with after this one is a design. What are the few of the best design patterns? Quality assurance and testing. As I said, it will help you to test your application in a very easy manner, because as it will be a very less testing, it will be less error prone, because your application, one application is not depending on another application. It should depend upon one application can depend upon another, but if any change is happening on one application or one module or one class, it should not impact indirectly or directly to another one. And last is maintainability, easier to maintain. And few others are collaboration. When multiple, what does collaboration, how we can take advantage? When multiple developers work on a project, adhering to solid principles make collaboration smoother. Developer can work on different part of the system with confidence that changes are less likely to cause unexpected issue in another areas. So these are the few the solid principles. And as I told you, why we need solid principles. Suppose that if one class is overloaded, just take an example, one class is overloaded, and I've seen more than one functionality, actually maintaining such classes will be very difficult. Classes should not be very much tightly coupled, because if you're changing any one functionality by default and you have to change to another classes also, you have to test it again. So Solid says choose proper principles and design pattern at the time of designing your software, and it is the developer responsibility to understand which principle to choose and patterns are best suited according to your situations. So solid principles are already tested and proven mechanism to make your software design more understandable and maintainable code. Now, if you'll ask me why do we really need solid design principles? So take an example. You are building an application. After some time, maybe application detected some bugs. To resolve those bugs, you come up with a resolution that you have to change the entire project design. Oh my god. So that's really, it is going to cost a lot of effort because you have built your application from the scratch, and you have given a lot of effort to build this application, and you figure it out that the complete design, the complete architecture of the application has to change. Or maybe you are in a project is already in production and working as expected, and you want to add some more feature in it, and you again come up with a solution that your design have some issue and have to redesign it. Okay, so suppose that you want to extend your feature, but after looking your code, the principles what you have followed, after looking those principles, you observed is like the complete entire design of that software has to change. So that's again a design problem. And you find one, suppose that another example is you find one bug, and to resolve those bugs you have to do full end-to-end testing, which is taking a lot of effort and hampering the existing client also. So if it is hampering existing client and taking a lot of company money and money, then it's again a problem. Company will not accept those things. So considering these problems, which is really costing lots of efforts and money to the company, Solid actually says how to design your software with some guidelines and principles. So these will help you in future with more maintainable, flexible, adaptable, testable, and with the help of parallel development also. So hope it is clear. There are a lot of theory in this session, but believe me, you will be enjoying more on our next session, which is coming on SRP, single responsibility principle, with real time example and very simple example, so you can adapt it easily. Thank you for watching. Thank you so much. Bye bye.